Hello, everyone. Thank you for taking the time to attend the Couchbase event with us. I'm Kamini Jagtiani. I'm Senior Engineering Manager at Couchbase for the Query team. Today, I will be talking to you about Index Advisor. Index Advisor is one of the tools that Couchbase has released so that you can create indexes for your workload with ease. The agenda for today's meeting is we'll be talking about advice statement, which went GA in 6.6, and it was available as a developer preview feature in Mad Hatter, which was 6.5. We'll also be talking about Index Advisor service, which is available to you free of cost, and an advisor functionality, which is used to give advice for multiple statements or for a session or for a workload. And that is going to go GA in 7.0, which is coming up next year. It's also available as a developer preview feature from 6.5. After that, I'll be giving you a demo for the advice statement, for the Index Advisor service, and for the advisor functionality. And then it's open for Q&A. You can also ask me questions during the presentation. I will be answering in the chat itself. So going directly into the presentation. Now when a query is basically submitted to the client, it comes down to the query service. The query service parses, analyzes, looks at the indexes which can service this particular query, and then sends the query to that index service. The index service scans it, filters it out, and then sees which are the documents which can satisfy these predicates, and then returns the keys or the meta IDs of those documents back to the query service. The query service takes a look at these meta IDs, sends them to the data service. The data service will then retrieve all those documents, send them back to the query service. Query service will then again apply the filters, joins, aggregates, and return the result back to the client. Now let's take an example and talk about this. So the example is right here, which is select statement. Now, if there was an index available on only CID, then the query service would select that index, and the index service would then look for documents where this predicate was getting satisfied. That is, the CID is 49165. Suppose the key for that was K01. So it would then send K01 back to the query service. Query service would then send K01 to the data service and retrieve the entire document associated with key K01. And then out of that, when the entire document came in, it would select the CID, C first, C last, and C max and display it back to the client. Now imagine if you had an index on not just CID, but if you had an index on CID, C first, C last, C max, and maybe a bunch of other fields, then in that case, query service would select that index because it looks for the predicate. It also looks for all the projections that are needed in the query. And it would then select that index. The index service would again validate the predicate. And instead of just returning K01, it would return all these fields back to the query service. Now the query service on receiving this would then not need to send a call to the data service for the document. As a result, you have saved now an extra network, right? And so the latencies have gone down. The query gets back, the results get back to the query faster. So if you have the right index, the query latencies can be reduced, your throughput can be increased, right? Now, in this query service, actually, there is an optimizer which selects what index will service this particular query or any query for that matter. Now, optimizer selects this index based on a certain set of rules, right? On a certain set of rules. Those rules are, if you're trying to create a composite index, then the fields in the composite index follow these rules. If there is an unless clause in the query, that field will come first, followed by equality, followed by in, followed by less than, greater than, and so on. So for example, if you had this query, select name from travel sample where ID was less than 100 and type is equal to route. Now you can see that equality comes before the less than. So the index that will be used for this will be type first and then ID, right? So that's the index that optimizer will look for. And maybe even covered index, like when we talked about only accessing the index service, it will also select it. If an index exists on type, ID, and say name, then it will select that ID. Now then it will select that index. So the indexes have to be created following these rules so that the optimizer selects that index, that particular index. So what is index advisor? So either you build your indexes based off these set of rules that we just presented, or you use the index advisor service. Now, index advisor service has been introduced in 6.5 as DP and 6.6 released. It's available for only enterprise customers. And what you do is you provide a query to the index advisor, and the index advisor will then recommend the appropriate indexes you should create so that the query will be returned with the lowest possible latencies. Okay, and it'll actually first take a look at the index, at the index which is already present on your system, to see it'll show you the index that your query will use during that service, and it will also show you the indexes that you could create for better output, for better throughput. And those indexes will be of two types. There will be covering index, which will cover the predicate and the projections, and also only the predicates, and also the non-covering index, which will cover only the predicates. And it's, like I said, it's available only in the enterprise product. I will next talk about who the index advisor is really useful for. Index advisor is basically useful for anybody who does not want to go and create indexes by looking at those rules. So if there was an application developer who was trying to develop a new application, then in that case, he can take those query statements, feed them to the index advisor, get the recommendation, create those indexes. Same thing with the enterprise DBA, somebody who is designing the database, who is designing the schema, or deploying a new application. So the workflow for index advisor, like I mentioned, it first takes a look. So this particular component is running in our query service. During the planner phase, it will take a look at the predicates, and then it will look at the projection. It will also look at the current index, which the query service would use right now. And then after that, looking at the predicate and projection, it will try to generate the index candidates, the covering index and the non-covering index candidates. It will then deduplicate those newly generated index candidates with the existing indexes and only show you the ones which you don't already have on the system. Also, for covering index, we go one step further and we validate the covering index, in the sense we try to create that index, we try to create a virtual index and make sure that the optimizer is actually selecting that particular index when the query is run. And after validation, we throw out the index output for the covering index and non-covering index. And my next slide shows you how the output looks. So you see the query statement here. It select name from travel sample where ID is less than 100 and type is equal to route, right? So the current index on your system, on this system, is on type. So that's the current index that's being used. Now it is recommending an index. You see this type equal to route, and we have multiple different types here because this is a bucket with many different types of documents. Since until now we've not had our bucket, our database and the table map the bucket. So we are basically it will suggest a partial index. So on type equal to route, And then it will create, since it's covering index, it will take ID less than 100. So ID will be the first field, which is the predicate, and then the projection, which is the name. So create index. This is the recommendation for covering index. And there is another recommendation, which is for non-covering index, which will be a smaller index, and that will be on type equal to route and travel and it will be on the field ID. So it will only be on the predicate. And we also have the rule, which is showing that the rules from the slide number 3, um, the same rules are being followed here. So we are taking the predicate type and then less than, greater than, and also flavor for partial index, right? We also mentioned the key space alias here. This is useful especially for join queries, and we'll see that further as we move on. Another example here, which is slightly more complicated as compared to the previous example. We are selecting name, city, public like. This is the key space, which is travel sample. We are trying to unnest because public like is an array. Now, if you go back to the rule, you see the unnest was the very first rule. So if there is an unnest involved, that has to be the first key in our index. Okay, so it takes a look at the current index on your system, and that's only available on type. Now for non-covering index, which should be easy, non-covering index is only on the predicates. So type is equal to hotel. It will go as a partial index where type is equal to hotel, and public like, which is there in the unnest clause. So we will do create index on travel sample all public likes where type is equal to hotel. If you want low latency, then in that case you have the index which you will create on the predicate and whatever is being projected. So that will be on public likes, which is the first one, and then name and city, right? And the key space alias is the same, travel sample B. So all this is, this screen that you're seeing is from 6.6, and it's available again only for the enterprise users. Now, we love our community users, and we are not going to force you to move to enterprise just for Index Advisor, right? So we have another service which is available on the web. It's the Index Advisor service. And what this does is you just supply a query to it. It doesn't need your bucket. It doesn't need your data. It takes a look at your query and generates the index recommendations. Now, because we do not have your bucket and we do not have your data and we do not have access to your indexes, this part wherein we were saying current index which is being used is going to be missing from the web index advisor. Now, who will use this index advisor service? This index advisor service is, as I said, is useful for the community edition users. It's also useful for users who are on older Couchbase servers like 6.0, where index advisor was not available. The optimizer has remained the same. So the index recommendations provided by our current index advisor will work on the older Couchbase servers. So you don't need to upgrade to 6.6 just to have the index advisor. You can continue to use your 6.0 server and you get the index recommendations from the index advisor service and create the indexes in 6.0. And that's about it. So I will also show you this is basically the index advisor service, right? And you can see this right here, and let's try to continue the presentation. So this is the example of the service. This is how the index advisor service looks on the web. I've given there is one example here where is select name from travel sample and bunch of these things. Then again, because we don't have access to your data, we cannot tell you which indexes are being used to service the query currently being used, but the recommendations are right here. So covering index, the recommendation is going to be on city, because equality was the first clause. City, free breakfast, free parking. Then we talk about the array count, right? And after that, we'll be talking about name. And for non-covered index, it's going to be all of the above without the name, right? The third type of functionality is advisor. So for advice, you always give just one query statement and you get back a bunch of recommendations. Now, what is advisor? Advisor is you can give multiple query statements at one time, and it will show you the recommendations for all those query statements. You can also have advisor job that can monitor. You can say that hey, I want to monitor for next 20 minutes all the queries that Kamini is running or the administrator is running. And then you generate indexes for all those queries, right? So that kind of functionality, like workload monitoring in a small way, is what is being done by advisor. So these are the various things you can do with advisor. You can say you start, you monitor the administrator, you monitor all the queries which run for longer than 3 seconds, and you do this for exactly 20 minutes. And the query count at most should be 2000. Okay. This, when you do, it will asynchronously keep running in the background, but it will give you a session ID. And then say you come back next day and you say, I want to get all the recommendations for this session ID. Then you can basically say action get session is so and so. It will give you all the recommendations for all the queries that came in. You can also go ahead and purge it, list it. If after 20, if you said 20 minutes but you want to stop it, say after 10 minutes, you can issue a stop and it will go and stop. Again, you can abort in the same way. The way advisor works is you start the session. As soon as you give this, you start the session. There is a task scheduler which is running, and it will start collecting every query following all the statements that following all the conditions that you set up initially. It will start recording all those statements in our system completed requests, and it will do that for the entire duration. Once the duration is over, it will then run advice on each of the queries which have been saved in the completed requests. And the results for the recommendations will be stored in the system task cache, which you can then retrieve using get. So for example, here, I'm saying select advisor, select raw statement from system completed requests. So it looks at all the statements that ran, and it says the statements that ran in that session were basically select star from travel sample and select this one. For that, the index that was used from the system was this one. And these are the recommendations these are the recommendations for the indexes that one should create for better output, right? I'll be going to the demos next, but this is our kind of the schedule. So 6.5 DP, we released the advice statement, and also the advisor for workload and the advisor for session handling, but all of it was developer preview. It was not thoroughly tested. In 6.6, we created the virtual key space, virtual indexes. We did some validation. We changed some priorities for the rules for the optimizer, and so the index advisor. And then in 7.0, we are introducing cost-based optimizer. And so our recommendations for the advice will now not be based on rule-based, but will be based on cost-based if the statistics are available. Okay, going to our demos now. This should be a familiar interface for people who have used 6.5 Couchbase server. This is our UI. You go to the query. That's where you can provide your, that's where you can get the advice. So let's take this as an example. You can see the predicates are type and country. And these are the projections. If you execute, you will see the result. But if you take advice, this is the advice. You can take a look in JSON format, which is something we have been looking for in the presentation or looking at in the presentation. Now, if you go back here, this is the current index which was being used. These are the recommendations for non-covering index. The recommendation is on equality first, country, followed by type. For covering index, it is country, type, and all the predicates. Country, type, and all the predicates. Taking a look at the next example. Again, advice, go to JSON. You will see that we have the unless clause, and here there is only one b dot type, which is hotel, and so we suggest a partial index on this. And once we suggest the partial, we select the partial, suggest the partial index on this, and this is the non-covering index, which is on the unless clause, and the covering index, which is on the unless clause followed by the projections. That's name, city. So public likes name and city. Let's take a look at a slightly more complicated example. Advice, actually execute, and you can see 43 documents which are retrieved. And if you take advice, these are the current set of indexes that are used. Now you can see here there are multiple key space aliases. One is airport, one is airline, and the one is airport, second is airline, and third is route. So here are the current indexes which are used, then the recommended covering indexes on each of those aliases, key space aliases, and the non-covering index recommendations. Okay, let's look at advisor, which was for workload monitoring. I have already put it in DP mode, and that's why you can see this preview mode right here. Here, instead of supplying multiple statements or starting a session, all I'm saying is take all the statements that I have run so far and that have been written to completed requests and provide advice on that. So when I do that, it shows me the current used indexes for each of the statements. And you can see these two statements are the same, but then because of the spaces, it's being counted as two separate statements. Like this statement has been run 3 times, so it will show me a run count of 3. And this is the currently used index. Then after that, there is recommendations for each recommended covering index, recommendation for this query, so these two queries, the recommendation is the same because obviously the query is the same. But here again, a recommendation for this and a recommendation for this query. So there will be covered index recommendations, non-covered index recommendations. It's a very verbose output depending on your space availability and need for latency. You decide what indexes you have to create. This will further be improved in the next few releases. Now, all this is available only for EE customers. So let's go to what's available for CE customers. And this is the index advisor that's available for CE customers. This is the interface. This is how it looks. This is the query. The only difference in that, and this is that you have to have advice in front of it. You supply the query, and you don't have to create any buckets here. Now, when you run it, you can see the index recommendations. You can increase the size right here. You will see the covered index, covering index recommendation and non-covering index recommendation, right? And again, this is on the same 3 key space aliases, airport, route, and airline, the query which I showed you before. We can take another one here. and run it. So this has advice in front of it, followed by the query. You run it. You see that here the predicates, there are 4 predicates. The first document type, this is on the equality, inequality, and then is not missing and is missing. So for non-covering index, it will be only on document type. First one, equality is complete, not equality, inequality, and then is not missing is missing. And for covered index, it will be all these 4 plus plus the projections, all the projections. So you can see the covering index can be really huge at times, and that's where you will have to decide what kind of index you want to you want to create. Um, and that's all for my presentation. Thank you very much again for coming over and attending this time and attending this presentation with us, and for all your time.